Okay, and so then with the 6 amp source, one of our mesh currents is set because the current in this in this branch here, we'll say, is forced to be 6 amps. And so now, you have to follow the procedure that we outlined, the step-by-step procedure for mesh analysis. So identify the meshes. Well, there's 3 of them, 3 loops that don't contain any other loops, so that means there's 3 meshes. And so I labeled them A, B, and C. And so I'll call this one mesh A. I'll call this one mesh B. And I call this one mesh C. So now what we're supposed to do then is to label 3 mesh currents, and they all got to be clockwise. So we have this one, IA. In mesh B then, IB. And in mesh C down here, IC. Now, a couple of things now we need to note. Okay, we have a 6 amp current that goes this way. So that means that IB here disagrees with the 6 amps with the direction, but not with the magnitude, because this current source forces the current in this branch to be 6 amps. So that means that IB is equal to negative 6 amps. And so, my intention, I'm putting that in there, was to simplify this to 2 unknowns. Okay, so now the direction with IB agrees with the polarity shown across the 2 ohm resistor here, Vx. And so the current enters on the positive end. So that means that that current that flows through there, I2 ohm, is equal to IB, which equals negative 6 amps. And so you should be able to start then by saying that that means that Vx is equal to I2 ohm times the 2 ohms, and that means negative 6 amps times 2 ohms and Vx is equal to negative 12 volts. And remember, the negative 12 is because of the polarity direction that's indicated here. So opposite to that, right? Okay, now next thing we got to do, if we're following along with mesh analysis, is show polarity on each resistor. Current enters the positive end, so IA is going around here clockwise, so this side of R1 is positive, this side of R3 is positive, and this side of R4 is positive. Okay, IB in the right mesh here, and so it goes up through R3, so positive on the bottom. It goes left to right through R2, so positive, negative, and that agrees with the polarity shown for Vx, but the polarity of Vx got nothing to do with the polarity of the mesh current, so we should write it in. For the 12 ohm, positive on the right. Likewise then, IC goes clockwise, so R4 on the IC side is positive on the left, negative on the right. Likewise for R5. R6 then, because he's on the bottom, we got current going through in the other direction, positive on the right, negative on the left. So we're going to start writing mesh currents now, mesh equations rather, and it's KVL around the loop. Our procedure told us to start in the lower left hand corner, go around clockwise, and include terms for all components. R1 got 1 current through it. If we're going in the direction of A, which is clockwise, we're going from positive to a negative, it's a voltage drop. So it's negative. The voltage drop across it is I times R, so 6 ohms times IA. Now the next we have a 20-volt source. If we're going clockwise, we're going down. Negative to a positive means a voltage rise, plus 20 volts. Okay, now the resistor here is shared resistor, 2 terms for him. So he's a voltage drop on the IA side, right? And remember where the direction is with respect to IA. So on the IA side, it's -3 times IA. And remember that all them polarities for IA are all going to be negative. So subtract 3 times IA. Now he got a second term. And remember, we're doing this from the point of view of mesh A, which is down. So from the IB side, you're going from a negative to a positive. And the 2 terms for each shared resistor always got opposite polarities. So that will be plus 3 times IB. Okay, so now we got another resistor down there, and I hardly got room to fit it in, so I should have started down here to give myself more room, I guess. So -6 IA, we had plus 20, subtract 3 IA, plus 3 IB, and so now that brings us to R4, and so remember now it's going to be -20 times IA, because all the terms with IA are going to be negative. And so, you know, the term then is a shared resistor. You got 2 terms, so it's plus 20 times IC, because the sign is going to be different for both terms. Now, because that is why we do mesh analysis during a very set procedure, because the similarities, right? That makes, I suppose, make it easy. But, you know, the reality of it is, look, from the direction of IA, we're going right to left across R4. So from the IA mesh side, it's a plus to a minus, which is a drop, so -20 IA. From the IC side, with respect to IA, it's a negative to a positive, so that's plus 20 IC, right? So then we got to take into account 2 mesh currents through there, 2 terms in the mesh equation for that resistor, 2 terms for all shared resistors. The mesh we're writing it for will be negative, the other one will be positive. That's, again, you do mesh analysis the same way every time. You get the similarities, makes it easy for you. Now, we can go ahead now and write this equation in terms of 3 variables. But remember that IB is -6. So we may as well take it into account down here, right? So we have -6 IA, -3 IA, -20 IA. So -29 times IA. The term with IB in it will be a constant now. So we'll move that across the equal sign and deal with it that way. So we have plus 20 times IC, and that is equal to, this plus 20 goes across, becomes -20. The term with IB in it goes across, becomes -3 times -6 amps for IB. And so this right side over here becomes -20 plus 18. So that becomes -2. So our equation number 1, -29 times IA plus 20 times IC equals -2. And that is then equation 1. Okay, so let's go with now mesh C. And remember now, we only got 2 unknowns. So mesh B current, we know is 6. There's not much point in writing an equation for that. We don't really need it. So for mesh C, start in the lower left hand corner. And so for mesh C, start in the lower left hand corner. The 20 ohm resistor is a shared resistor. So from the IC side, we're going in the direction of IC, which is left to right. So from the IC side, we got positive to a negative. So that's a voltage drop. So that's negative 20 times IC. Remember, that one gets two terms. So we got to do it from the direction of IC, but with respect to IA. So on the IA side, we're going from a negative to a positive. So that's a voltage rise. So that's plus 20 times IA, right? And so that's two terms for that shared resistor. Now, you see a lot of people do that as one single term, where the current through the 20 ohm is IC minus IA, right? So, you could write this as negative 20 multiplied by the current through the resistor is the sum or difference of two mesh currents, IC plus IA. And so that gives you, and it's actually the difference between the two currents, right? And so that's why I'll use two terms, because I make less mistakes. And so then that's a negative sign, because the IC and IA goes through there in different directions. So it's the difference between them. So we got negative 20 times IC. Negative 20 times negative IA is plus 20 times IA. So a lot of people writes that like this. Okay, add those two terms for the shared resistors, right? Okay, so our next resistor is R5. And so in a very similar way now, from IC direction, which is left to right, on the C mesh side, it's a plus to a negative. So that is, again, subtract 12 times IC. And two terms for that resistor, because it's a shared resistor. And so with respect to IC, we're still going left to right. But from the mesh B side, it's a negative to a positive. So that's plus 12 times IB. And so, with respect to doing this the same way every time in our similarities, see, negative 20 IC, negative 12 IC. Plus 20 IA, plus 12 IB. So in a way, before you start this, because we're doing this mesh the same as the last one, you should already have the polarities down pat, because you notice that every term with IC in it is going to be negative, and the second term for each of the shared resistors will be positive, as long as you got the appropriate mesh currents. R4 got IC and IA through it because it's shared between mesh C and mesh A. R5, the 12 ohm, got IC and IB through it because it's shared between meshes C and B, right? Okay, so that brings us to R6. R6 is down there, not shared. So it's just negative 8 times IC. Right, so one term for that resistor because he's not shared. Then we comes to the 30 volt source. We're going from in the direction of IC, it's crossed this way. We're going from a positive to a negative, so that's a voltage drop. So that's subtract 30. Now we're back to our starting point, so that sum is equal to 0. Okay, so we have plus 20 times IA. There's three terms with IB in it, there's one term with IB in it, but we know IB, negative 6 amps. So then, that becomes a constant because we know what that term is. There's three terms with IC in it, minus 20, minus 12, and minus 8. So we have minus 40 times IC is equal to, we're going to take our 30, bring it across the equal sign, we got plus 30. Take our term with IB in it, bring it across the equal sign, it's, it's negative 6 times 12, which is negative 72. It brings it across the equal sign, it becomes plus 72. Now, remember, it was plus 12 IB, so negative 12 times IB, and so that was negative 12 times negative 6. So plus 72. And plus 30 and plus 72 is 102. So that equation became 20 times IB. Now, I got a problem there. That was IA I'm supposed to be having there, isn't it? And so I'm sorry about that, because this was IA here, because IB was our known, right? It's this term right here that went there. So it's 20 times IA and minus 40 times IC is equal to 102. And that became equation number 2. And so there's only 2 unknowns here, right? And so that is equation 2. So next, you can do this by substitution. Now, relatively easy. You only got 2 equations, 2 unknowns. Our matrix solution says for equation 1, negative 29 times IA, 20 times IC. Our second equation, 20 times IA, negative 40 times IC. The inverse of that matrix multiplied by the matrix of constants, which is negative 2 and 102, gives us the solution, which is, in this case, IA and IC. And so when you put that in your calculator, you come out with IA is equal to negative 2.58, and it's a current, so the unit is amps. IC is equal to negative 3.84, and again the unit is amps. The negative sign means they're both counterclockwise, but mesh analysis is easiest if you do it the same way all the time, and so they're always deemed or assumed to be clockwise, and again the negative values means counterclockwise. And remember, now part of the solution was IB. IB is equal to negative 6 amps. So there's our solution. Now, the question asked us to find Vx, which we already answered, negative 12, and Ix. So let's go back now and think about what Ix is. And let's size up our circuit, right? Okay, so let's go back to the circuit. Ix is up through R3. Okay, so it's the magnitude of I3, but it's up through. Now, remember, 2 mesh currents goes through R3. IB is up, so he's positive. IA, down, disagrees with the direction of Ix. He's negative. So Ix then is equal to IB subtract IA. And for IB, we had negative 6. So then we're going to subtract IA, which was negative 2.58. And so Ix then, negative 6 plus 2.58, which is negative 3.42 amps. Well, I could have done a better job with that, but let's see. Now, let me erase this part here, and Ix equals negative 3.42 amps. Now again, think about what the negative sign means. The negative sign means that we have indicated the direction of Ix be up, it actually goes down. Well, let's think about that. The 20-volt source got his positive terminal on the bottom, so he probably produces a current that goes down. The 6 amp source, if he contributes anything to that, he also goes down. Yeah, it makes sense that that goes down, right? The 30-volt source produces a current that goes this way, and so we're not sure what his contribution to this is. Could be up, could be down, but the idea is that probably the net current through there agrees with down, so we would think that negative makes sense. Okay. Now,